Hello and welcome back. Now let's do an example about the reference node, which will further clarify any confusions you might have about this concept. So what we are given is this circuit, which is composed of 5 elements: x1, x2, x3, x4, and x5. So these are connected in this way, and we are asked to mention all node voltages if the datum node is first, if we take node D as the datum node, and in the second case, if node C is taken as the datum node. So nodes are also mentioned in the question. So if you look carefully, there are 5 elements and hence there are 5 branches of this circuit. We have 4 nodes A, B, C, and D, out of which node A and C, these are simple nodes because they are only connecting 2 elements, while node D and B, these are not simple nodes. And also, what is given to us is all the branch voltages. Remember, these are branch voltages because these are not referencing to any datum node. So we are asked to find node voltages at the 3 nodes while choosing the 4th node as the datum node. So to solve this question, here I have created 2 copies of the same exact circuit, and in this case, in the first case, we are going to take node D as the datum node, and here we are going to take node C as the datum node, and then we will find all the node voltages. So all this writing in red, this is what came with the question, and now I'm going to write the solution with the blue marker. So first of all, in this first case, let's choose point or node D as the datum node, and I'm going to draw this datum node symbol. And of course, this datum node is going to have a voltage of 0. Now before that, let's look at a concept about voltages. So if we have this, let's say this 5-volt voltage source, so what this means is that the positive terminal has a 5-volt potential higher than the potential at the negative terminal. Or this also means that the negative terminal is at a 5-volt potential lower than that at the positive terminal. So using this concept, this is the 0 volt. Now what is the voltage at node C? For that, we have to look at this x5 element and its polarity. So this terminal is 2 volts higher than the negative terminal, while negative terminal is connected to 0, while 2 volts higher than that is going to be 2 volts. So node C is going to have a potential of 2 volt. Now let's look at the voltage of B. For that, we have to reference to x3. So its negative terminal is connected to ground, which is 0. So its positive terminal has to be 5 volts higher than its negative terminal, which is 0. So 5 volts higher than 0 is going to be 5 volts. So VB is going to be 5 volt. And lastly, we have to find the node voltage at VA. And what is that? It is by looking at x1, we can see that its negative terminal is connected to ground or 0, and its positive terminal has to be 1 volt higher than its negative terminal. So 1 volt higher than 0 is going to be 1 volt. So that is how we have found out all the node voltages for this circuit. And we can further verify our results by looking at x2. So x2, its voltage enforces that its positive terminal is 4 volts higher than its negative terminal. So you can see the positive terminal, which is node B, it is 5 volts, which is 4 volts higher than the negative terminal, which is node A, with a voltage of 1 volt. Similarly, we can further verify VB and VC looking at x4. So it says that its positive terminal is 3 volts higher than its negative terminal, which is true because its positive terminal VB is 5 volts, which is 3 volts higher than VC, which is 2 volts. So in this way, I have already found all these results and I have further verified it by looking at x2 and x4. So that was part 1, and now let's do part 2 where we need to consider node C as the datum node. So first of all, I will draw this ground symbol. I will connect it to node C, making this node voltage 0. And accordingly, all other node voltages are going to be affected. However, the branch voltages are going to be exactly the same as they are because they are not referencing to the datum node. Now we can solve them one by one. First of all, the node B is simplest because here looking at X4, it says that its positive terminal is 3 volts higher than the negative terminal. Now, negative terminal is connected to 0. Its positive terminal, which is 3 volts higher than 0, has to be plus 3 volts. So VB is 3 volt. Now VD, here you can see that this X5 enforces that its positive terminal is 2 volts higher than the negative terminal, or otherwise we can also say that its negative terminal is 2 volts lesser than its positive terminal. Now positive terminal is connected to 0, so 2 volts lesser than 0 is going to be minus 2 volts. So in this case, VD has to be minus 2 volt. Similarly, as from the knowledge about nodes, we know that all these points on a single node are going to have the same potential. So if this end is minus 2 volt, this end is also going to be minus 2 volt. So let me write it down here, although there is no need to. Now let's find out the potential or node voltage at A. This X1, its polarity enforces that its negative terminal is 1 volt lower than the positive terminal, or its positive terminal is 1 volt higher than the negative terminal. Now the negative terminal is minus 2 volts. Going from this point, node D to node A, from minus 2 volts, I have to further add 1 volt to reach point A. So minus 2 volt plus 1 volt is minus 1 volt, which means voltage at point A is going to be minus 1 volt. So these are our solutions, and we can further verify them by looking at the polarities across X2 and X3. First of all, the polarity across X2 enforces that its positive terminal has to be 4 volts higher than the negative terminal. And if you look at the difference between VA and VB, that is also exactly 4 volts. So VB is 4 volts higher than VA, which is exactly what this is enforcing. So our VA and VB are correct. Similarly, X3 enforces that the difference between VB and VD is going to be 5 volts. And if you look at VB, which is 3 volts, and VD, which is minus 2 volt, the difference between them is exactly 5 volts. So that is how we can tell that our solutions are correct. So I hope this further clarifies the concept of reference node. Thank you for watching, and see you in the next lesson.